Here, here. Come witness the tale of a lone Mesa developer who, after the 101st regression caused by external changes, vowed to slay the bisection dragon once and for all by guarding the driver kingdom with CI pre-merge testing.
Ever since I landed support for my driver in Mesa, I've been spending more and more of my time fighting regressions instead of adding features. I'm fed up with manual testing. I need to figure out a way to invest on CI. So what's the minimum amount of work I can do to just run my test scripts on my dots from GitLab? So I could just use the GitLab runner directly. It's the minimum amount of work. So it's been working. Let's see how stable it is so I can go from just post-merge to pre-merge. So after a while, it's been stable for weeks, but now the jobs are suddenly failing. But it's fixed after a reboot. This is weird. And now it's broken again? What's going on?
All right. Someone just tried on your device some unstable, build, and it broke your GPU state. But, it's like you work from home, right? So you will just go to your device and turn it off and on again, right? No problems, right?
Okay, but now that doesn't boot anymore.
Oh, right. So, yeah, what happened is that developer decided to test an LC1 kernel, Linux kernel, and then there was an XFS or X4 regression, and it just corrupted your drive. Just reinstall everything and you're done.
Okay. Well, now this is a weird one. The random tests are failing, and there doesn't seem to be any pattern in the job.
Don't worry. It's not your fault. It's just, some developer tested some feature and it changed the GPU state, and now it's in the state of wrongly set up GPU, but you're testing something, so it's failing.
Okay, that's great. So now I installed some security updates, but my network doesn't work anymore. How do I get back to a working state?
Right. You need to figure out what package actually broke your testing, and then you need to revert that and pray that everything works again.
Okay, that's good. And now someone keeps pushing a fake job that's just installing a cryptocurrency miner. I keep killing it, but it comes back.
All right. Well, your machine is compromised, so have a fun reinstalling it and wiping clean and take care about it.
Okay. Well, okay. But now my machines are running 24/7 to wait for a job to arrive, and that consumes a lot of electricity, and it's just heating up my apartment where there's already another heat wave starting.
Yeah, that's the problem when you run the GitLab runner directly on your test devices and let them idle when they are not being used. So, yeah. Next slide.
Okay, well, that doesn't seem worth it. Okay, so clearly I need a stable environment so that I can rely on its state and make sure I can test it before I push it to prod, because if I make a mistake, I need to be able to revert. And yeah, the dot, it needs to be in a clean state, so I need to parrot it down before each job. Yeah, it has to be already powered down when I start the job so that I can just boot it from a clean slate. So I guess I need to boot it on demand. I think I need an infrastructure for this. I can't do it just with GitLab runner directly. Does Mesa have something to do? Something to do that?
Yeah, sure, Eric. But you will need a few things which you need to set up. So first, you need a gateway, so you can connect gateway to device under the test and do the testing itself. You will also need like some serial ports to be able to send commands and retrieve output of these commands. And of course, you will need PDUs to devices to shut down and power on to devices when you need them. And of course, some network switch, so you can like communicate, download containers and rootfs and everything, right?
Okay, well, that's not too bad. I already have most of these anyway.
Right, but then when you start using an infrastructure, then you get a new set of challenges. One of them is that you're going to stress test the boot of your devices. So if they don't boot reliably, then you're in for a treat. Also, additionally, I mean, the nice part is that you're going to be having a very spiky load. So by default, when the machine is unused, then you consume about 60 watts, not bad. And then whenever the machines are working, then you can go up to 600. So yeah, you're idling at 10%, so not too bad. And then next, the problem is that if your device is relying on a battery, like for instance, or here a Steam Deck or a laptop or a phone, then if the battery is still connected, then if you want to want to shut it down, the machine, and guarantee that you can shut it down, then you can just disconnect it from the power using the PDU. It's going to keep on running for, well, if it's an Apple M1, then probably about a day or two. So you don't want to wait that long. So you want to be able to cut the power when you need to. So what you do is, you literally cut the wire. And then you connect it to a relay that you control using another cable, which is basically connected to the power supply through, for instance, a USB charger. And this is how you automate testing on battery-operated devices. But that's more work.
So I have the bare metal infrastructure. So what's going to happen if my CI gateway won't start after the update, right? So I will have to go there, I will have to fix it manually, that's not that great, right? And another thing, for device under the test, since I recently built my lab grid setup, which originally should be one of the part of this talk, it's like you need to write all the configuration by hand in the config files, and you have to be very careful which serial cable connect to which device, and if you need to replace something, it's pretty annoying, yeah. So if you switch the cables, it's like some device randomly is starting getting some output of commands and boot, and you're thinking what's happened, right? So, and also you need to maintain the configuration of each device. So this is one example how it can look. And for each device, you have one of this file. So that's not that appealing, right?
Yeah, okay. I think we need to split out the configuration and everything for the infrastructure away from the code, away from the device, so that it's factored out.
Away from the project that is being tested.
Yeah.
So rather than duplicating the same code in every single project, then you just have it in one place and then you just talk to this infrastructure.
And maintaining all of that configuration for each device by hand, that's too much work. We're going to make mistakes. It's not going to work. We need to auto-discover the machines, verify at boot that the machine hasn't been, like you haven't swapped the GPU while the machine was off. All of that needs to be automated. We can't do that by hand. And that rootfs deployment, like having to transfer the data over the NFS between the gateway and the DOT, that's just slow, and that doesn't work. Bare metal has some trade-off, but that's not really that much better. Do we have something else in Mesa?
Okay, so we have Lava, right? And with Lava, it solves some issues like prioritization, and the configuration is a little bit nicer than for bare metal. But still, Right, new slide. So still you need separate the duties, you need generate rootfs, you need to work with templates. So for example, if you're booting different devices, for some devices with U-boot, so some devices with fastboot, you need alternative templates for each device. So that's not that much fun. And what is missing in Lava, and we miss that a lot, is like, for example, the interactive session where you can like connect to the device and look what's happening and interact with it, just not retrying the job again and waiting until it starts and test your changes. So it has some drawbacks.
Okay, so that doesn't really fit what I want. What I really want is like a system that's just simple. Just keep it stupid simple. I want a simple dashboard that just tells me what the devices, what the test devices I have that are connected. I want to just use the same job description as GitLab, not a custom one. I want everything on my device to be automatically discovered. Like if I change something, I want that I don't want to do anything manually, which also means I need to not have to care about how to boot the device, and I need automatically to have automatic monitoring as well, so that I don't have to keep an eye on every device to see when something goes wrong. And I really want to just be able, if there's a job that fails on the CI, I want to just be able to, with a simple command, just run that locally without having to just construct by hand a ton of things. And yeah, so containers, that seems to fit some of that. I can have the boot process is standardized if it's just a Docker image that I boot. And I can do that on the DUT that I test, but it would be good to also have that on the gateway so that I don't have to maintain the gateway by hand. And that way I can just test one image on the gateway, and if there's an issue, I can just roll back to the previous image and I'm done. And yeah, in an interactive session, that would be really nice. Like if there's a job that's failing, instead of just retrying, like you said, just connect to the job while it's running and see what's going on it. Or just take over that device because something's wrong with that device. So I'm not gonna run it on the CI anymore. I'm just gonna run something myself, type my commands and figure things out, but without having the CI using it. And yeah, it would be nice to be able to use it from GitLab, but also from GitHub, SourceHut, or anything else. And I really want the jobs from merge to come first, so that if there's a bunch of users that are testing things, they're not going to prevent the people who want to merge something. So there needs to be prioritization that actually takes merge before everything else. And if we have some like a long job that's running in the background, and it's like a nightly job or something like that, and someone wants to merge something, I need to kill the nightly job, run the merge job, but then I want to just resume, not have to restart the 3-hour job that was killed after 2.5 hours. So I want to be able to just preempt the job, like kill it, but then resume and not restart.
So yeah, about that, here is Citron. And now you can see the lemon part that I was talking about. So yeah, so in Citron we have quite a few things out of this. So we have this nice and simple dashboard, as you'll see in a second. Unfortunately, we don't have yet the Forge native job description format, but the entire architecture of the project is geared towards this. So that's not next on our to-do list, but the one right after. Then automatic discovery and recovery of devices under test. Yep, that's there since day 0. I don't trust myself to, you know, when you have 10 machines and then you think you're modifying test machine 3, but you're actually modifying test machine 4. Then you've got 2 GPUs that look pretty much exactly the same, and you plug just one that you think is the right one, but then you plug the wrong one. This is not, you know, like hypothetical. This is happening all the time. And yeah, so this is something that I don't trust myself with, and I don't have to. Then the boot standardization, this is something that, so we ended up going for PXE booting or iPXE. So PXE is basically what people call net booting, right? And iPXE is just a super cool bootloader. And if your board doesn't have support for it, then you can flash, let's say, U-boot. That just runs iPXE as an EFI bootloader. And so it's fine. So the test projects don't have to know how to boot the machine. This is something that the dot itself should be configured to do. Then, well, automatic monitoring. So both of the gateways and the test machines, whenever they run a job, then they're just gonna send statistics about their CPU usage or RAM or GTT utilization, I don't know, whatever you want. It's there. Then being able to run the CI job in an identical environment. So for instance, in Mesa CI, we just output the job description, and then you just copy that, and then you run the same command line that was used. So that's a single line, so it's pretty good. Then we run containers with everything. The way we boot these containers is through an initramfs that we created. It's called boot to container. So it's 20 megs, so you just download it every single time, and it stays in RAM. So if it gets corrupted by, let's say, kernel that is unreleased and with X.Org corruption issues, then doesn't matter. The drive is only used for one thing. It's just caching, and if it doesn't work, if the cache is corrupted, it's just gonna nuke it and start again. It doesn't matter. It's just a performance improvement. It is not. Yeah, it is not something that you have to have. Yeah, so changing, testing ahead of production. We have a CI system for our CI system. Whenever you send a merge request to CItron, it's gonna deploy a virtual environment that just has virtual dots that are gonna be booted and tested, and the entire life cycle of machines is tested like this. And if it passes, then probably good. And we're not done with that yet, but we have a branch where we even test GitLab jobs from this GitLab job. So it just, a bit more meta. So that's how you test from end to end the entire system ahead of production. I'm fed up with working like hacking in production. That is not okay. Then usable for multiple instances of GitLab. So that is done. So you can expose your dots on multiple farms, not farms, like GitLab instances. So in gitlab.com and then freedesktop.gitlab.org, for instance. The opposite. GitHub is not done yet, but this is on the roadmap. SourceHut is an example, and then, I don't know, GTA, whatever. The objective would be that you don't even need to do anything. It would just be using the Forge native job description. But it takes a little bit of time because you need to re-implement the job, the runner. So, but that's doable. Simon did it, so he gave me a pep talk. Then to prioritize jobs for instance, Marge, so Mesa CI's workflow, or Mesa's workflow. This is in progress. We have a solution that is generic for everyone, and then we'll have to adapt it for CItron to make it even more powerful. And then finally, the job preemption. This is something that was designed from the beginning, but we have not worked on the interruption yet, but the resumed part is there. So that means that, for instance, in some test suites, if your test suite supports resuming, then you can already, if the machine hangs, it can reboot and continue from where it left off. So that with Piglet or IGT, this is supported. But for Mesa CI, which is using the EQP runner, there's no support for this yet, but we'll need to add support for it. And yeah, so now let's have a look a bit at how it looks. So this is an old photo of my farm. Now it is a little more crowded. That was the first 3 devices that I put. Now here we've got about 8 Steam Decks, but it was too messy, so it just went for the old photo. So what do you see? You have a gateway here that is controlling the PDU here that you can see, not. Here you've got the network. And then, so of course you can control the gateway and the test machines using a KVM screen and keyboard. So that's practical if you want to see what is going on. Of course on laptops it's very nice because you don't have to stay on Steam Decks. Yeah, and that's all there is. So every DOT needs 3 things: power, serial, and Ethernet. So that's it. That's what you find here. Oh, you need to be...
Oh, yeah. So that's an example of the dashboard that you get that shows you all the devices connected to your farm. This one is, we made it simple, so there's just one device that's going to be there. I'll show you an image of something we have in prod after, so you can see a bunch of different devices connected. So at the top here is the line you want to be looking at. So you have a PDU here, that's a Shelly plug. It's one of those like small 1 per dot kind of thing. You saw a picture earlier of one PDU that has like 8 ports, I think, or something like that. So yeah, you have both options. You buy a big one and you plug a bunch of devices, or you buy 1 per device. So here it was just a Shelly plug, so 1 for the dot. And right now the port is off, so it hasn't been turned on yet, so it has no idea what's there. The system knows nothing. And so we're going to just press the discover button here. And now we get into the discovering state. So the first thing that happens is it turns on the power on that plug, and the device is going to boot up. First thing the device is going to do is going to try to connect to the network, do a DHCP request, and from that we're going to get the first bit of information we get from the device. The DHCP request contains a byte, or is it just one byte?
Yeah, it's a single byte.
Single byte, yeah. That encodes a few informations, and from that we get that, in this case, this is an ARM64 device, booting using UEFI and TFTP for the files. And when it's in that state, that's just DHCP request gave us that information, and then we, in the response, we give it an image through IPXC that is going to boot and is going to do some discovering, basically, of what's on the device. And once it's done doing that first round of discovering what's on the device, we have more information now. It's not just an ARM64, it's actually a Broadcom chip, BCM2711 with a VC5 GPU. So that's a Raspberry Pi 4. So we get that information from the discovery. And I think we forgot to take a screenshot of the details.
Yeah, I realized.
So we actually have a lot more information than that, which is exposed in the form of tags that you can use in the GitLab job. You can say, I want a device that has BCM5 GPU, for instance, and it's going to give you anything that has that. Probably not many other options that do, but maybe you can say, I want a Navi21. Whatever device has a Navi21 on it, give me one of those. And you have tags like that for what kind of CPU it is, what kind of GPU, how much RAM you have. If you have tests that need more RAM, you can say, okay, these tests only run if you have at least 8 gigs of RAM. That's the kind of tags you get through the automatic discovery. Again, you don't have to configure anything manually. All of that just happened when clicking one button, discover. So it says training 1 out of 20 because we want to make sure that we always get, so we can boot reliably. It's not going to sometimes boot, sometimes just hang. And we want to make sure that every time we boot, we get the actual same content on the device, all the sub-devices. And you don't have like enumeration that sometimes works, sometimes not, so you get weird things there. It happens. So to make sure that this doesn't happen, we have that 20 rounds of training, or it's just going to boot. check what's on there, report it back, boot, check what's on there, etc. 20 times, and if at least 19 of those 20 times give you the same result, then the device is going to be ready and it's just idle, which means it's off, no power consumed, and it's waiting to receive a job. And if you want to do some maintenance or something like that, you can just press that retire button here, and now it's retired, which means it's not going to accept any jobs anymore. And yeah, you can reactivate it if you want. Well, you probably want. And like say that on a Raspberry Pi, you're not going to do that, but on an x86, like say you change the GPU and you plug another one in there. When you click the activate button, it's going to do a quick check, which is basically the same thing again. It's just going to do one time this time. Boot, enumerates all the devices and updates all of the tags if you change the Navi 21 to Navi 31.
No, not update. Just verify that nothing changed.
Oh, it doesn't...
No, if something changes, it's going to go back to training.
Oh, right, yes.
Yeah. So it's just a quick check that nothing changed.
Yeah, and the quick check is running. And then it's ready, and yeah, nothing changed here. And so yeah, that's the image of the Keyword Studios, which is one of the farms that we have, with a bunch of GPUs here. You have the generation and the specific GPU in that generation, and then just a number. If you have a bunch of those, you have 1, 2, 3, 4. And again, we should have taken a screenshot of the details. If you click more, you get all of the tags that describe all the details about the hardware.
Yeah, and there's also more actions that you can do rather than having just a single one. So,
yeah.
For instance, turn on the port or not, right, on this one. But it's dependent on the context. Yeah, and so you can see here that having the list of just the name and that you can trust that this is really what is connected is really important when you're working with remote farms. So if you're hosting your machines not at home but in a lab somewhere, then which is, if you have enough devices, it has to be like this. Then you have technicians working on it, and then they don't necessarily know your system or the project that you're testing. So being able to double check that they say that they did this, and then you can verify that it actually is the way it was supposed to be. That is super practical. And then they can also use this dashboard to verify that things are in the state that they were expecting it to be. So that's why the dashboard was made, really. Next.
Okay. So the product is hosted on GitLab FreeStop, GFX CI for the namespace. CItron is the overall project, but one of the main thing that we mentioned is boot to container. Actually, boot to iPXE first. If your device doesn't have iPXE supported, then you can use boot to iPXE to have iPXE on your device. And then from that, you can use boot to container to just say, I want that container, and it's going to download it, cache it if you have a disk or something that can do the caching locally, and start it. And you can have services in the background, like monitoring and things like that. And then CItron is the overall project that puts all of that together. And some people might want some of that, like just the boot to container to start that. They can just reuse that component without using the rest of the infra. Oh, and we have an RSC channel that we just created for support. We're going to talk when talking dev, so you can follow along if you're interested in how the development of the project. And if you have questions when you use it or anything like that, please come ask us on that RSC channel on OFTC. Okay, so that was us. And last information is that this afternoon, as you heard, just after lunch, which has been pushed back a little bit, we're going to have a workshop to show you how to set that up. If you have, so you don't have to bring anything, like you really do not need anything, you can just come, show up and see how it is. If you have a device that you want to test, bring it along to just like really do the thing yourself to see how it is. It is very simple, you're gonna see that, so yeah.
I mean, it's very simple unless it is an ARM device, but because of course, you know, U-boot stuff. But yeah, if it's x86, it's fully transparent, and Raspberry Pis are fine or things like this, but not everything is supported by boot to iPXE. But yeah, we'll have 3 gateways that you can play with. So one of them is x86 based, and then 2 of them are Rockchip based, so ARM64. And then we'll have for each of these gateways 2 test devices. One ARM, I mean, all of them have one ARM64 and one x86. So, and one of them is a Steam Deck. Just saying. And yeah, do you have any question?
No, it doesn't work.
It's not on.
Yeah, how suitable is it to test not only the user space but also the kernel? Because I see that basically you boot to the yeah. Sorry.
No, it's not sorry. It's like it's designed for this.
Yeah. So.
How suitable? Very suitable. In my previous job, I was testing the kernel, and so I know that it is the hardest requirements. So this is like that's the all the knowledge that I got at Intel, like working on the Intel graphics CI. This has been like distilled down into okay, this is what we need, and then I rebuilt everything in a way that would work for all the projects. Not, of course, not just the kernel, but yeah.
Yeah, because what I saw, it was most containers and etc. And this does not really work for in kernel stuff. So how can we use it for kernel?
Well, I mean, unless you have a kernel that is not Linux, then you're fine. Is that a kernel that is not Linux?
No, it is Linux, of course.
See, then there's no problem. It's just config options that you need to set. So
one thing that we didn't mention is that the kernel that you boot there is downloaded every time. I mean, it's cached if you want to cache locally, but it's downloaded.
It's not cached.
Oh,
okay.
My bad. But anyway, it's downloaded from the network. You can just give a different URL for the whatever local build you did. You pushed on some server, give the URL, and you're going to test that kernel.
Okay, and the second question, how tied is it to iPXE? So for example, can we, how hard would it be for us to integrate a different kernel sharing mechanism? So for example, this device will not have iPXE.
Yeah. So net booting is just a very convenient interface. I think fast boot could be implemented, like automatic fast boot discovery. What I don't want is to end up in a situation where you have to write in the config file, this is how I boot. I hate this. I don't trust myself. I don't want to do that. But I think we were discussing this with Ryan at some point, and he was saying that, yeah, we can do this with fast boot, have this, well, just based on the USB ID, just figure out that this is something that is just appearing and then use that. And yeah, so I believe that fast boot is should be doable. Then, so iPXE is just something that I really appreciate, but then we also would like to have this Pixie Linux support from U-boot. U-boot is not as nice because it's not going to give you all the information like from the SMBIOS table. So if, for instance, you want to have a different kernel just for the Raspberry Pi, then you can't really tell using U-boot. It doesn't give you this information, but iPXE actually allows you to send this information, so that's a bit more powerful. But we still want to add support for this. So if your device is using, like works well with mainline, then you wouldn't have to do anything, and then U-boot could be just the vendor one, and that would work. I wanted to add support for that for this, workshop, but I did not have time to do that. But yeah, I mean, iPXE is not a requirement; it's just one way. Yeah.
I wanted to ask about any plans to do video capture or remote KVM capabilities. Anything you're looking at right now?
So what would you want from there?
Also, obviously, you're testing GPUs, and ultimately, you would like to see what's coming out of the HDMI port, or maybe look at what's on a laptop screen, and then being able to remotely just look at what's happening on a DID could also be interesting, right?
So this is something that we were working on quite a bit with Simon in front of you, working on the Google Chameleon project. So basically, it's like an ARM and FPGA board that you put next to your DUT, and then you connect the HDMI or DP to it, and then you connect it back to the DUT using USB or Ethernet, and then you can access the frame buffers that were sent, get information about the info frame and shit like this. If it's just like you want to be able to see what is the output, but just as a casual thing, then just install a KVM, like a network KVM, and then like plug your test devices to that. That's what we do. But this is, if you want automation, then you need to be able to control things, and then the test device itself is the most suited to have the synchronization points. And yeah, something like the Chameleon would be needed. But yeah, unfortunately, the Chameleon is not readily available. It's outdated, and we've been discussing about improving it for, I don't know, 6-7 years. And we have plans, but then, like if someone is interested in writing a lot of Verilog or any sort of HDL and do board design and all this, then yeah, please come and talk. That's something that we would like to have. But that's more like for kernel testing or display testing, which I was working at Intel on, but not anymore, or not my priority anymore.
Does the system performs any kind of monitoring of the DUTs? So if something is broken, like the serial cable doesn't work anymore, the system just retires automatically the DUT from testing?
Do you want to answer that? Yeah, we actually do have something like this. So if it is if it is really outright not working, then at every single boot that we do before running any job, we verify that the state of the machine is still matching the one from the database, and that includes a test of the serial console. So we send a ping, and then we get a pong. We have a service, yeah, maybe it wasn't super clear from the presentation, but we don't say that, hey, this serial console is attached to this particular device, right? At no point in the presentation we had to do that. That's because we have a service called Salad that is literally just looking for every single serial device that is connected to the gateway, and then it's gonna be snooping on the connection, and then, like the serial logs, to figure out which machine is connected to it. So there is this little protocol that you can have in order to associate the machine. So that's one thing. But then after this, through the serial console, we can actually like grep on certain strings, and then if, for instance, we get a kernel hang or a GPU hang or something like this, you don't have to wait for the timeout of the job. You can just reboot automatically and then retry. And so the way we do this is that if you want, you don't have to reuse the same kernel command line as you did for the first job, so that if you want to resume, then you can have a different command line. So, but yeah, it's not mandatory. If you don't use it, then it's just going to reuse the start configuration. Mm-mm.
How does the configuration work for devices that don't automatically boot when powered's applied? Like you were talking about attaching like a relay to the Steam Deck. Like, is there any configuration required?
So for the relay, it's a funny thing that I did. I think I was pretty happy with it. It's dumb. So you have the PDU, and then rather than connecting the PDU directly to the Steam Deck's power supply, you just use a power strip. And then you just like bring the power to the Steam Deck, and then you use a USB, like power supply, whatever, like phone charger, and then you plug that to the relay, so that the two of them are always in sync. And luckily, the the power sequence of the Steam Deck or any other device really is going to be much slower than connecting the battery. So the battery is going to be connected by the time the BIOS or the embedded controller is starting, and so it's as if the battery had been connected the entire time. Yeah. To get there took me a couple of iterations. But yeah, it's dumb because but it works, so it's smart.
One thing to note about battery devices is that the battery needs to stay there. I don't know if it's the case on that
Oh yeah,
one.
that's something. Yeah, so for some devices, the performance is going to be highly affected by whether the battery is connected or not. So for some, you can just disconnect it and you're done. But for most devices nowadays, you cannot just power it using USB and not have a battery. It's going to crash, or the BIOS is going to limit your performance or firmware. And then you were saying, like, what can we do for devices that don't boot on AC? Well, I have one device like this. It's not reliable, so I have a small Arduino that just has a relay and then just keeps pressing the button until the power LED turns on. That's literally what it does. I mean, it's not like physically, it's electronic, but yeah, that's what it does. And I'm gonna make it as its own PCB that people can just print using like GL PCB or whatever, so that you can order 100 of them and then you're done. Yeah. So right now I just do it by hand because it's so small, and yeah, that would just be the like 5th iteration of this PCB, you know, over the years. Mm-hmm. Okay, well, thank you very much for listening. Hope it wasn't too boring.